For this lab, Lab 3, Magnetic Dipoles, we were tasked to find the magnetic dipole moment of a bar magnet. We also had to use a magnetometer app and Excel to record and analyze our data. In this lab, we also had to use the equation for the electric field of a dipole and the distance dependence equation given here. For the first part of our lab, we needed to compensate for the magnetic field of Earth. To do this, we had to zero out the x component of the magnetic field. Then we taped a ruler perpendicular to the phone, and this ensured that the only thing affecting the x component of the magnetic field was the magnet. We then had to find the sensor on our phone by placing our phone horizontally and finding a maximum of x, and then vertically finding a maximum in y. For the next step, we had to find the distance where the magnetic field on the x-axis equaled a certain amount. We recorded this data into Excel, and Excel then gave us a natural log graph that gave us n and the natural log of k. From our data, you can see that the value given for n is -3, which we expected it to be around 3, and the value of the natural log of k was 14.748. And then using this information, we solved for q using the on-axis equation for the magnetic dipole, and we also used the distance dependence equation that was given in the lab. And I rearranged these both equations to find that mu was equal to k over 2 times the magnetic constant. So we found that mu was equal to 1.96786 amps per meter squared. Then we found the off-axis distance, and we followed the same initial setup, and we found d perpendicular so that the magnetic field was equal to 100 microtesla. And we used the setup that is pictured here, and Excel gave us the distance d, and it also gave us the net magnetic field at that location, a distance d perp away. And this is the data for that, and we will compare that, the data for the BNet to the BNet that we get in the code. For the coding section of this lab, we had to model the magnet and its magnetic fields with GlowScript. To do this, I created a magnet and 6 arrows representing the fields at different locations using the dipole formula. 2 of the arrows were on axis, the others were perpendicular to the axis, and 1 was at a 45-degree angle. As you can see in my coding picture here, you see that the blue arrows are the perpendicular and the orange arrows on the on-axis. The purple arrow is the one that indicates the 45-degree off-axis, and you can see that the magnetic field at a distance d was equal to those components. But I went and found the net field to be 3.11 e -7, and that measured differently from the net field given to me by Excel. Some thoughts that we could have for this lab, though, in general, that I saw was that the magnetic field increased as the magnetometer moved closer to the magnet. If the Earth magnetic field wasn't accounted for, the value measured would not be solely from the magnet, and if 2 connected magnets were used, then the magnetic field would be twice as strong. Again, my mu was this value given, and the reasoning I have behind the BNets being different is that there was a lot of interference either from metal or electronics. I redid the lab twice. I couldn't find a way to make that part of the experiment match up. But thank you for listening to my lab. I hope you all have a great day or a great night.